Hi, for this chapter, gravity, we'll be doing 3 structured questions and 1 essay question. So remember to download the material from the link below in the description. So let's start. So with Slango set 1, we'll be looking at what is escape velocity. So escape velocity, remember, don't get confused with this because we have such thing called a linear velocity. We also have something known as an escape velocity. So what is the difference between that is when you see escape. So the word escape usually means that it has to run away from something, right? So can be run away from Earth lah, can be run away from Jupiter lah, can be run away from any planets. So what is the meaning of escape velocity? This is the minimum velocity required by an object. Okay, so it could be a rocket, or it could be a person, or it could be an object. Okay, required by object to escape the gravitational, okay, here you got 2 charts, you can see, to escape the gravitational potential energy, or you can also say to escape this thing called the gravitational force from surface of planet. Okay, because you have to escape this thing from the surface of the planet to outer space. Okay, remember, try not to write Earth because it could be any random planet. So in this situation, this question, this is your Jupiter. Now, so take the escape velocity of Jupiter, means you want to escape from Jupiter, will depends on the mass of Jupiter or mass of the rocket. Okay, so this is a very good question. Okay, imagine if now I've got a thin guy versus a fat guy. Okay, now if both of us wants to escape from Jupiter, who needs a higher velocity? Now the answer is actually you need the same velocity. Okay, kenapa? Now because whenever we look at all these formulas, right? Now a lot of people will tell me, teacher, very simple ma, can't they give you the formula already, v equals to 2gm over r? Or even for escape, linear velocity is gm over r, escape will be v equals to square root 2gm over r. However, it is very important for you to know this m is actually representing which mass. For example, kenapa the escape, why the linear velocity is like this, why the escape velocity is like this? In this video, I'll tell you about it. Now, so for linear velocity, usually means that that thing is actually rotating around the planet. Usually it means that there is a rotation around the planet. So when there's a rotation around the planet, there is such thing known as gravitational force, and also there's such thing known as centripetal force. So these 2 forces must be balanced, alright? So your gravitational force is actually gmm over r square. Your centripetal force is mv square over r. Don't worry, these 2 formulas will be provided in the formula sheet. So what you have to nampak here is that the small m will cut each other. So meaning to say that this is the small m, this is the big M. So the big M represents the bigger object. So that's why here you are left with your V square, here you are left with your gm over r. So your this V square will be square root of that. So this is actually the mass of the bigger object. So mass of the planet, alright, because it's big M. So this one important or not? I think it's very important because in exam, they might call you to maybe prove that the M is the mass of the planet. So takkan you say, oh, because big M, so must be mass of planet. So in this case, you must learn how to prove a little bit, guys, remember. Okay, for this 2gm over r, kenapa is like this? Okay, because when it comes to escape velocity, there's something related to kinetic energy. So there's half mv squared. You want to escape all the way to the top, so there's something called your gravitational potential energy. So for me, I will say that my kinetic energy must be equals to my gravitational potential energy. So half mv squared is going to be equals to gmm over r. Okay? So you can even find this in your textbook. So if you cut the small m, you put this to the other side. So your v squared will be equals to 2gm over r. Then you square root this. So also prove to you that the small m has already cancelled each other out. Meaning to say that the remaining one is the big mass of Jupiter. Okay. So remember, I'm saying what if in exam they want you to prove that the mass is big mass. You have to show this equation and show both small m is already potong one, already cut one. Then next calculate the escape velocity of the Jupiter. So for a lot of people who memorize formula, okay, you will rugi sangat, okay, you will lose a lot of marks because when you see here, okay, because this is big M, correct? If you don't know that this is mass of Jupiter, if you thought this is mass of rocket, you will lose 1 mark. Calculation, you lose another 2 marks. Here, they purposely kacau you. Kenapa? They gave you the mass of rocket, okay? And they also gave you the mass of Jupiter. So they purposely try to confuse you. So a lot of people will add the mass together, but actually tak payah. So you just keep this very simple. You just have to make sure that, okay, this is 2. So your G is 6.67 times 10 to the power of negative 11. So this gravitational constant can be found in your formula sheet in front. You need to use that because in exam, they won't give you the G value in the question. Alright? Okay, so what is the mass of the Jupiter? It is 1.9 times 10 to the power 27. 1.9 times 10 to the power 27. And then after that, what about the R? R is the radius of the orbit. They got give me a lot. Got 6.99 radius of your Jupiter. Okay, actually they should give you the radius of the Jupiter in meters. Sometimes they will purposely give you in km. So this one you pun kena tahu lah. You have to be careful with all these tricks So 6.99 times 10 to the power 7. Boom boom. Then if you calculate this properly out, you should get something like 6.022 times 10 to the power of 4 meter per second. Okay. Oh no, sorry. It's 6.2 times 10 to the power of 3 meter per second. Calculated wrongly already. Okay, can no problem. Okay, so the only trick here is the mass of the Jupiter. Not add the mass together, okay? So next, or you can also write 6022 meter per second. Okay, because it's the same. 60,000. It's 6.022 times 10 to the power 4 meter per second. So in this case, we will see this is 60,000. Okay, because 6022 times 10 to the power 4 is equivalent to 60,220 meter per second, right? Correct. So will it be able to escape to the outer space? Okay, we calculated that in order to escape, you need 60220. Now your rocket only got 60,000, means it's less than the velocity that you need, right? Imagine you need 60220. But now you need got 60,000, means lesser than that. So can it escape to outer space? The answer is cannot. The answer is cannot. Or you can just say no. Okay, cannot escape to outer space because less than the minimum velocity required. So this is our first structured question. Okay, let's look at our second structured question. So I need you guys to write down so that you will remember this better. For our second structured question, we will look at this one whereby we talk about satellite P and satellite Q. Okay, so now when we look at this P, Q, and planet, okay, I want you all to have this very sensitive thing. Okay, when I see two objects, remember, in the picture where there's three objects, biasanya, okay, and these three objects are very special. One must have two objects going around one of the object, means one of it is the center point. Okay, so you see you got P, Q orbiting the Earth, three objects, P and Q orbiting Earth. So these two objects will orbit the Earth, which is the one object lah. So when I look at this thing, immediately I know this is going to be related to Kepler's law lah, okay? So what's the force that caused... So I just try to imagine this Kepler's law, put it in the back of my head first, okay? Because I do this question, this is going to be related to Kepler's law. So let's look at this question first. So name the force that causes the satellite to orbit the Earth. So what is the force here? So remember, no, if you want to orbit, your FG dengan FC must be balanced. So in this question here, since they never say who tarik who or whatever, both answers are acceptable. You can say it is your gravitational force, or ataupun you can also say that will be your centripetal force. Centripetal force. Okay, Ken? No problem. Now next, okay. So now they tell you what they give you the orbital period, and they give you the orbital period of P. And they give you the radius of Earth. And what else they give you? Well, this one, they give you the km. Okay. So this will be related to our Kepler's third law. Okay, just now I said two objects going around one object, total three objects. So in Kepler's third law, there's such thing called the T square over R cube equals to T square over R cube. We use Kepler's third law to do comparison between two objects going around the same point. So I can use satellite P punya T square over R cube to be equals to satellite Q punya T square over R cube. Why? Because they go around the same point, because they go around Earth. Faham, right? Okay. Now, however, I'm going to ask you a question. Can we take T square over R cube, T square over R cube, of let's say Earth punya T square over R cube? T is the time taken for it to go around the sun. then equals to Mars punya t square going around the sun. R will be the radius of the orbit, radius of orbit. So is this valid? No. Can I use t squared over r cubed of Earth equals to t squared over r cubed of Mars? Can or not? Now the answer is yes, I can. It's valid. Okay, but when we look at, can I use Earth punya t square over r cubed to be equals to Moon punya t square over r cubed? Yes or no? Now for this one, cannot work. Alright, this is not valid. So this is not valid. Okay, can anybody tell me why? Now, if you know the answer, can you just write it in the description below? I will check your answer and other people can also refer to the answer in the description below. Feel free to leave a comment. Now, so we'll continue with this, okay? Earth, Moon cannot, but Earth, Mars can. PQ can, okay, PQ can. So now what do we need to do is usually, okay, for P and Q, I'm just going to write a small P and Q same, which is my t squared over r cubed and t squared r cubed the same. So I'm just going to write this here. Okay, I'm going to like make it small first. So now, Q punya time is minutes. Do I need to change it to seconds? Now, because both sides is t squared, both sides is r cubed, so this is a comparison of ratio. So I don't necessarily need to change this to, not necessarily I need to change it to seconds. I can leave it in terms of minutes, hours, days. Janji, if here I use minute, on the left, it must also be minute. Okay, means it has to be balanced, alright? So, you have to remember, okay, I write min, then I write min here. Okay, so now 8.2. Then I'm trying to find the time, the orbital period of satellite P. So this is P punya lah. Then what about the R? How do I write that? Now remember, your radius of Earth, your P is actually radius of Earth plus the 830 km, right? So for this one, I will change it to meters, okay? Because why? Ini km, ini meter. So this is quite tricky one. This is in meter km, this is in meters. So they purposely try to mislead you. So when you do this, make sure you write this properly. 6.37 times 10 to the power 6. That is the radius of the Earth first. I'm going to add 830,000 meters. So 830,000 meters. I bracket the whole thing, baru I put cube. Remember, your whole entire thing is add first, then you bracket cube. Alright? Then for Q, 685 km. So we just repeat the same step. We're gonna, for Q, write 6.37 times 10 to the power 6. 685,000 meters cubed. So here, what I'm doing here is I add the height, this is the radius of Earth. Bracket whole thing, I cube it. So at the end, when I calculate this properly, I'll get 101.655 minutes. Okay, why? Because it's in minutes, so I dapat minutes. Okay, 3 marks question. Easy, right? Okay, so t squared over r cubed, no problem. Okay, so next. What will happen to the orbital period if the orbital radius of satellite P increases? So, I don't know if you guys know this now, but what is the meaning of Kepler's third law? So, there's a definition. They say that the period of orbit, the period of satellite, orbital period, is actually directly proportional to the cube of the orbital radius. So, kalau your orbital radius increase, then obviously your time must always increase because this is directly proportional. The bigger the radius, the bigger the circle you have to run, obviously you will take more time, right? Because you run a larger circle, right? So the orbital period increases. You increase the time taken. Okay, can boleh Okay, so this is our second question. Okay, however, at the same time, I just want to remind you all, make sure you try this kind of question, like the compare mass, compare orbit, compare orbital period, because after that, when you see this question, right, 2 object, 1 center. So what is this? 1, 2, 3, Kepler's third law. So look at this thing, state the law involved. This is the Kepler's third law also. Remember, you have to write full name, Kepler's third law. Okay, Ken? Now, so if you see SBP, there is a lot of like Kepler's second law, Kepler's first law and everything. Now, let's look at our third question. For our third question, we will be looking at our Perlis question. Okay, so for this Perlis question, it's a very simple question because when I look at this shape, this is either Kepler's first law ataupun Kepler's second law. Okay, we look at what is the shape of the orbit. So this one is called an elliptical shape. So you can call this ellipse shape, or some they'll call it as an elliptical shape. So in physics, we don't really care so much on the English choice of words. You can say ellipse, elliptical, pun boleh. Alright. Now, so this is first related to Kepler's first law. It says that your orbit is elliptical shape, and where is your sun? Remember, the sun is at one of its focus, not at the center, at one of its focus. Okay, so this is the elliptical shape focus. Now, then when we look at this, wow, you see they put all these section guide. So this is related to something what we call Kepler's second law. Okay, what is related to Kepler's second law? Second also got two things the same. What are the two things the same? Okay, I let you choose time, speed, and area. So which two of these is the same? The answer is time, area the same, speed not the same. Okay, why speed not the same? Now, because the law of physics is when you are nearer to the sun, okay, it means you are more likely to be attracted, correct? So imagine if you see a handsome guy. If you are very near to the handsome guy, you will kena tarik, right? You'll be attracted to the handsome guy, right? Correct? So you don't want to get attracted by the handsome guy because malu kan. So what must you do? You must run faster, lor. So the nearer you are to the sun, your gravitational force more. So you will need a higher centripetal force so that you don't get sucked into or attracted or get pulled into the sun. Okay? Now, but when you are very, very, very far away from the very handsome sun, okay, very far from the handsome guy, so what will you do? You will slow down, right? Okay, why? Because you want to like chui tengok ma, less malu ma, right? So when your gravitational force is lesser here, then your centripetal force can be lesser. So speed is different. Nearer will be faster because more gravitational force, so you need a higher centripetal force. Faham ah? Okay. Now, so at which point this one will move with the highest linear velocity? So obviously the nearest one lah. So you must run faster, right? So therefore this is point A when you are too near. And it will be the minimum velocity when you are the furthest. So which one is the furthest here? This is your point G. So oleh itu di sini point G. That is your maximum. Why? Because this is near. Then why? Because this is far. Okay, can ah? No problem ah? Okay, but don't write the explanation ah. This one I write for you to understand. Okay, then state Kepler's ketiga. Okay, so what's my Kepler's third law? My Kepler's third law very simple. Just now I said already. It is t squared directly proportional to r cubed. So we can say that the square of your orbital period, because t squared is directly proportional to cube of r is what? Orbital radius. Okay, so basically it's just you add the word orbit front. So that's the orbital radius. Cube square is your orbital period. That guys, one mark, very simple. So since Kepler's law is now a recent trend, I highly recommend you to memorize your first, second, third Kepler's law. Make sure you do it. And then now we look at the calculation. Okay, for this one, right, it should be in terms of radius of Earth. Okay, it should be in RB, not RO. Okay, this question may not be a problem. So what do we want to, what they are trying to want you to find here? They say that find the distance of O to the sun. So takkan I give the answer in terms of RO, right? It will be in terms of RB, right? So now, okay, we see first. Okay, imagine this is the sun. Okay, imagine this is the sun. So they say that Earth pushing like that, okay, and then after that is 1 year. Planet O is 12 years. So planet O is obviously lebih jauh, further right, correct? Why? Because it takes longer time. You run a bigger circle, you take longer time. Very common sense. So can I use t squared over r cubed? T squared over r cubed, can or not? Okay, we analyze. So here got three objects. Planet O, Earth and Sun. Planet O and Earth rotate around the Sun. So dual, two rotate around the same point, then yes. So my Earth and my planet O can equate. Now, but this question, right, if you try and like solve it yourself, you will realize that they didn't actually give you the radius of Earth. So takpe, you can write RB cubed, then radius of this one is RO cubed, which means that you have to learn how to do in terms of unknown. So this is the radius of orbit of B. Okay, why I write B is because I write bumi lah, okay? Okay, the one that we write in terms of Earth. So I'm just gonna change it to RE or RE lah. Okay, so this is gonna be RE. Radius of Earth. Not radius of Earth, it's the orbital radius of Earth. Then what about the other one? Okay, this one, alright, radius of orbit of the O lah, planet O lah. So therefore I have RE and RO already. Okay, no problem. Earth is 1 year, then the O is 12 years. So now how to solve this thing? Very simple. So therefore, I shift my RO up. So my RO cube will be equals to 12 square R Earth cube. Okay, so now this will becomes 144. Then because square ma, so now I'm going to cube root this, shift this thing cube root to the other side. Then this one is RE. So my answer is cube root of 144 RE, radius of Earth. So that's why this is simpler. If you check this, this is 2 marks only. Alright, some of the question is in 3 marks because this one in terms of unknown, actually in terms of unknown is simpler. It's just that no number you will feel a bit insecure initially lah. You will feel a bit insecure. Okay, so therefore this is our strategy to do Kepler's third law. So this is our third question already. Now we are going to see our last essay question for today, okay, which is our Negeri Penang one. Okay, so the first question is very similar. Okay, you will see that for gravity, the questions are quite similar. So when I see this shape, I know what this is. Second law. Time, area, same, speed, different. What is the shape of this orbit? So like I said, you can say ellipse shape, or you can even say it is an elliptical shape. Alright. Okay, so elliptical shape. Now, compare the length of arc, the area, the linear. Okay, in order to save time, what I will do is that I will just, like use greater or smaller than R. Okay, length of arc ma. So obviously AB is going to be longer than CD. In exam, you write full sentences. Here we truly too long a bit. Calculate the area. Okay, they tell you that the time taken is equal. So time, same. What will be the same? Your area also must be the same lah. So if I compare the area covered, AB same, CD same, so we can say the area of FAB is same as your FCD. So the FAB and your FCD area will be the same. 1 mark, very simple. What about the linear speed? Wow. Linear speed different. Okay, AB is nearer, so therefore we can say AB faster than CD. Nearer, higher speed, right? Or you can say that the linear speed is higher than CD. So if you want to say faster, linear speed is higher than CD. So you get 3 marks comparison. So what's the relationship between the time taken and the area? Okay, so we can say when the time taken and the area covered are the same, then definitely the next question they'll ask you, because your time and area is the same, right? So which law? So this is your Kepler's second law. Alright, you can write the 2 lah, okay? Now, I don't know if you pernah dengar this law, but some teachers say you can just write Kepler's law, no need to say number what. Wow, are you sure, teacher? Of course must write second lah. Takkan, let's say for example, Newton got so many law, I just write Newton's law. Cannot write. Do you know that for the gravity, one very common mistake is they'll ask you the G_mm over R square. What is this law, right? Many people will write, oh, this is called the Newton law of gravitation. Okay, this answer is wrong, and a lot of people cannot tell what is wrong with this answer. The answer, kurang apa, is Newton's universal law of gravitation. The word universal very important because this is like the whole universe. Technically, Junhao is attracted to the sun right now. Okay, because it has no range. Okay, meaning to say it can go anywhere. Can no problem. Okay, then for this 4 marks question, okay, they'll say explain what is one benefit and one implication, means one negative of high escape velocity on humans. Okay, what is the problem, advantage and disadvantage of high escape velocity? Okay, so when you have high escape velocity, means Earth punya gravitation is very strong, right? Correct. Now, I don't know if you all know this or not, but one of the reasons why people can stay on Earth is because Earth is so strong that it can attract all the molecule. Okay, so we can say that one benefit is that all air molecules are attracted to Earth. Okay, they're all the air molecules are attracted to Earth, so they will not escape, so that it can form atmosphere. It can form atmosphere for human to live. Okay, if there is no atmosphere, you cannot breathe. So why oxygen will fly to outer space? Because Earth can direct the oxygen, everything to the center so that you can breathe normally. So I can say all molecules are attracted to the Earth, will not escape, so it can form an atmosphere for humans to live. So this is the benefit. Okay, but what's the implication? What is the disadvantage? Okay, so the third mark, I'm going to talk about the negative. So 1.1 elaboration. So your implication is the negative one. So what's so bad about it? Oh, no problem, we can just say the bad is that you need it has a high escape velocity for rockets or for like whatever lah, for space shuttle or whatever. So if you have high escape velocity, then upper problem. So you need more energy is required to launch rockets. Okay, more energy is a negative thing because more energy means more fuel is required. Means you have to burn more minyak. Means that chances are, one day if we run out of energy, we cannot send rocket anymore. Okay, if we run out of energy, we cannot send rocket anymore. Okay, alright. So more fuel is required to launch a rocket. More, you need to burn more and everything. So 2 advantages in blue, 2 disadvantages in red. Okay. Last part of our essay question. Okay, this essay question, if really come out, is going to be one of the weirdest and most complicated question. Okay, because it's going to be very complicated. They ask, this is for transportation from Earth to the moon to students in the field. So means you have to go to moon, pushing one circle and then come back. Alright, so this is quite tricky. Okay, we look at what are the points they want us to write first. Return to Earth safely. How to save fuel. Altitude orbit around the moon, transmission rate, and mass of ships. Okay, what is transmission rate? I think it's not transmission rate. I think they are looking for the halaju pelancaran. I guess so, not yeah, okay, Daribumi. I think they direct translated is the launch velocity. So this is the escape velocity lah. Okay, so step 1, how to return to Earth safely. So we can just say that we can move the, okay, what is this called? This is a space shuttle ships. Okay, so it's a ship. Move ship. Spaceship is also a ship to Earth gravitational field and turn off the engine. Okay, so what is this? What's the advantage of this? Okay, so when you master Earth punya gravitational field, how can you return to Earth safely? Is that once you like go into Earth punya gravitational field, once you shut down the engine, the Earth will actually help you to pull the spaceship back to Earth. So when you move ship to the Earth gravitation and turn off the engine, so we can say that the gravitational force of Earth will pull the ship to surface without needing help. What's help? Help from engine. So basically, the gravitational, it will pull the ship back. So how to come back down safely? You don't need the rocket to help you. You muscle the Earth will automatically help you to pull you down, meaning to say that you confirm will land on Earth. Alright? You confirm will land on Earth. So the secret here is that you have to enter Earth gravitational field, then you turn off the engine. Okay, can. Now, how to save fuel? Save fuel is during while you are going around the moon. Okay, so you can say when orbiting moon, the engine can be switched off. Okay, so okay, let's try to understand this thing. Okay, now when you orbit around the moon, okay, let's say imagine this moon. So you have a spaceship. So your spaceship want to go around the moon. So once your Fg is equals to Fc, meaning to say that once your linear velocity, your orbital velocity, linear velocity v equals to gm over r, once you reach this velocity already, let's say the velocity is 500 lah. So you move until 500 already, right? You can switch off the engine. Then this satellite will turn 500, 500, 500, 500. Okay, let me ask you a question. A satellite orbiting around the moon, will it slow down? The answer is no. Why? Because in reality, why a moving object will slow down is because got friction, got air resistance. In outer space, there is no air because it's space. So you will not have air resistance. So no friction, right? So why will the rocket slow down? It will just travel at constant speed. It's just like Earth, right? Earth got no rocket, no engine, no power, right? But why Earth won't stop? Because there's no air resistance, so Earth will maintain the motion. Okay, Ken? Alright? Now, so we can say that the ship can orbit moon at constant velocity with the gravitational force of moon equals to centripetal force. Okay, so basically here you have to say your gravitational force of the moon is actually equals to the centripetal force of the rocket lah. Constant velocity, it will just maintain in the same orbit lah. So you can say at constant height or anything. So obviously when you look at this question can be quite tricky. This question can be quite tricky. The third one, what about the altitude orbit around the moon? Okay, if you go near the moon, can you go very near to the moon? Cannot, because you takut when you go too near. If you go too near to the moon, later you get attracted in, then very hard for you to keluar sekali lagi. Okay? So we can say that when you orbit a high altitude during moon orbit. Okay, why must you orbit at a high altitude? So that you have lesser gravitational force from moon. Okay, so what's the advantage? So that it will take lesser energy required to return to Earth from moon. Okay, because if you are at a higher altitude, means that you are less likely to kena tarik by moon. If you less likely to kena tarik by moon, means that it's easier for you to return. Okay, Ken? So means that you can fly away easily. If you orbit higher, less likely to kena tarik. Okay, so guys, for this kind of question, you need to process a little bit. I chose this question to do is because I think this question, if keluar, so many people will die. Okay. Okay, what about the velocity? Okay, we can say you need to have higher velocity, or you can say at least same as your escape velocity. Okay, why you want to same as escape velocity? So that you can escape the gravitational field of Earth to move to moon, like that lah. Okay, so what you're trying to run away from, you want to escape the gravitational field of Earth. Where do you want to go to? You want to go to moon. So this is actually about space exploration. This question is very difficult, but it came up in state paper. So lebih kurang you have to know how to do, because everybody will do state paper. Okay, make sure you know this thing lah. Okay, then lastly, simple one, mass of ship. So we can say what we want here is the lower mass of ship. So why? Okay, guys, please don't say lesser escape velocity, lesser velocity, because remember, your escape velocity is affected by mass of the planet, not the mass of the rocket. Remember. So what's the advantage of lower mass? So I can say that I have lesser gravitational potential energy. Okay, or you can say lesser kinetic energy needed to escape Earth. Okay, why lesser kinetic energy? Because mass, in kinetic energy, there's a half mv square here, so there is a mass. So if you have lower mass, means you have lesser kinetic energy. You need lesser kinetic energy to overcome the lower potential energy. Okay, so therefore it's easier for you to escape Earth lah, in that sense lah. Okay, so I use energy instead of I use velocity. Alright, now for this question, I speed through the whole entire question because I think it's difficult, but I think like this one only maybe got like 25% chance to come out in the exam, so it's less than half. Make sure you read through this. If you have any questions, feel free to leave it in the comment section below. I will reply the comment section ASAP, probably on Saturday night. Thank you everybody for watching this video. So we'll see you again in the next episode.